December 14th, 1943, outside Zhytomyr, Ukraine. Soviet armorer Sergeant Pavel Dmitriev watched through binoculars as his unit's best marksman, Junior Sergeant Nikolai Belov, lined up a shot at a German officer 400 meters across the frozen field. The SVT-40 barked once. Through the scope, Dmitriev saw the impact, center mass. The German staggered, then kept walking. Belov fired again. Another hit. The officer clutched his chest but didn't fall. He made it behind cover. Dmitriev's throat tightened. This was the fourth engagement that week where confirmed torso hits on German soldiers produced no kills. Something had changed in the enemy's equipment. The standard 7.62 4mm cartridge, the same round that had served Russian marksmen since the Mosin Nagant, was failing to penetrate. Intelligence reports from other sectors confirmed it. German assault units were wearing new body armor, steel plates that stopped rifle rounds at combat distances. Soviet doctrine had no answer. The PPSH submachine guns were useless beyond 100 meters. The bolt-action Mosin rifles were too slow for the fast-moving winter offensives. And now the semi-automatic SVT-40, the rifle that was supposed to give Soviet riflemen fire superiority, couldn't punch through enemy protection. That night, Belov came to Dmitriev's workshop, carrying something that would have gotten both men court-martialed if discovered. What this veteran sniper had designed in desperation, and what Dmitriev would help him perfect, would spread through Soviet rifle companies as an underground modification that commanders quietly ignored because it kept their men alive and the enemy dying. By late 1943, the Eastern Front had transformed into a grinding meat grinder, where small advantages in firepower could determine whether an assault succeeded or collapsed in blood. The Red Army had finally seized the initiative after Stalingrad and Kursk, pushing westward in a winter offensive that reclaimed vast stretches of occupied Soviet territory. But victory came at horrific cost. Soviet rifle divisions were losing men faster than they could train replacements, and every inefficient kill translated to more casualties as battles dragged on. The SVT-40 had entered service in 1940 as the Soviet Union's answer to the American M1 Garand, a gas-operated semi-automatic rifle that could theoretically give the average Soviet rifleman twice the fire rate of German soldiers with their bolt-action Kar-98K rifles. Designed by Fyodor Tokarev, the same engineer behind the TT-33 pistol, the SVT-40 fired the standard 7.62 4mm cartridge from a 10-round magazine and weighed just under 4 kilograms. Soviet production had manufactured over 1.6 million by mid-1943. In practice, the rifle had proven temperamental. Its tight tolerances and sensitive gas system fouled easily in mud and extreme cold. Many frontline soldiers returned to the rugged Mosin Nagant bolt action, which worked reliably even when caked with frozen blood and dirt. But for trained marksmen who could maintain their weapons properly, the SVT-40 offered a devastating advantage. A skilled shooter could place accurate follow-up shots on target in seconds, crucial for engaging German squads equipped with rapid-fire MG-42 machine guns. What made the situation in late 1943 particularly devastating was the introduction of German body armor to frontline units. Intelligence reports from multiple fronts described two types: soft armor made of layered silk and hard plates of manganese steel worn over the chest and groin by assault engineers, flamethrower operators, and some infantry officers. The Sappenpanzer plates weighed roughly 3.5 kilograms and could stop pistol rounds and rifle bullets that had lost velocity at range. The statistics backed up the desperation. Soviet after-action reports from the Zhytomyr-Berdichev offensive documented engagement ranges averaging 300 to 500 meters across open winter terrain. At those distances, the 7.62 4mm light ball ammunition issued to most infantry traveling at approximately 2,800 feet per second from the SVT-40's 24-inch barrel, retained enough energy to penetrate 10 millimeters of steel at 300 meters under ideal conditions. German armor plates measured 2 to 4 millimeters thick, but angled presentation and the round's design meant penetration was inconsistent. Marksmen who encountered armored targets described the frustration in blunt terms. One report from the 240th Rifle Division stated, confirmed hits on enemy officers at 400 meters produced visible impact but no effect. Target remained combat effective. Follow-up shots to head or extremities required, wasting ammunition and exposing shooter position. The problem wasn't just psychological. In fluid winter combat where German counterattacks could materialize within minutes, stopping enemy leaders and squad commanders quickly was essential to disrupting enemy coordination. An officer who survived long enough to call in mortars or organize his men could turn the tide of an entire company's assault. Soviet tactical doctrine emphasized eliminating enemy leadership first, but body armor was nullifying that advantage. For Soviet armorers and marksmen, conventional solutions weren't available. The Red Army couldn't simply issue armor-piercing ammunition to infantry. The standard 7.62 AK-54 mm FAR B-32 armor-piercing incendiary round existed but was reserved for anti-aircraft machine guns and heavy machine gun crews. Distribution to rifle units was prohibited by regulation. The rounds were in short supply, needed for their intended purpose, and considered too valuable to expend on individual rifles. Soviet logistics were already strained supporting the massive winter offensive. Priority went to tanks, artillery shells, and fuel. That left frontline soldiers to improvise their own solutions. German confidence in their new protective equipment was well-founded. The Sappenpanzer body armor had been tested extensively against captured Soviet rifles at Wehrmacht proving grounds. At 300 meters, standard 7.6254 mm light ball ammunition from a Mosin Nagant produced inconsistent penetration against the 3 mm plates. The SVT-40 performed marginally better due to its longer barrel and higher velocity, but reliable penetration still required perfect perpendicular impacts, something combat conditions rarely provided. German combat reports from the period reflected tactical arrogance. One Heer battalion commander's diary from December 1943, captured later in the war, noted, "Soviet marksmen have proven ineffective against our assault engineers. The steel provides sufficient protection at normal engagement ranges. Their semi-automatic rifles deliver rapid fire but insufficient penetration. We advance with impunity where previously we would have suffered officer casualties." What they couldn't have known was how quickly Soviet soldiers would adapt. The Red Army's strength had never been superior equipment or comfortable logistics. It was resourcefulness born from desperation and commanders who understood that survival sometimes meant ignoring regulations. Soviet rifle units facing armored Germans attempted several solutions that winter. Some marksmen aimed exclusively for headshots, but this required perfect conditions and wasted valuable time lining up difficult angles. Others tried to close engagement ranges to under 200 meters where velocity remained higher, but this exposed riflemen to devastating German machine gun fire. A few enterprising soldiers attempted to scavenge B-32 armor-piercing rounds from machine gun positions, only to face discipline when supply sergeants discovered missing ammunition. The fundamental problem was regulatory and practical. Soviet small arms ammunition production was strictly segregated by type: light ball for infantry rifles, heavy ball for machine guns, armor-piercing incendiary for anti-aircraft and special purposes. The system worked for industrial production and logistics, but it left riflemen without options when they encountered threats that standard ammunition couldn't handle. Even more frustrating was the knowledge that armor-piercing ammunition existed. Marksmen knew that B-32 rounds, with their hardened steel cores and incendiary compound, could punch through German armor plates reliably at 600 meters. But those rounds sat in machine gun bunkers and ammunition depots, off limits to rifle squads. The regulations made sense from a strategic perspective. Anti-aircraft defense was critical as the Luftwaffe still controlled contested airspace, but it offered no comfort to a sniper watching his target walk away after a perfect shot. By mid-December 1943, the situation had become critical enough that some rifle company commanders began submitting requests through channels for armor-piercing ammunition allocation to designated marksmen. The requests went nowhere. The logistics apparatus had no mechanism to redistribute specialized ammunition in small quantities to frontline rifle units. The system was designed for mass production and mass distribution, not tactical flexibility. Then came an unexpected solution, not from Soviet weapons laboratories or the upper command structure, but from a veteran sniper who decided that staying alive mattered more than following regulations. Junior Sergeant Nikolai Belov was not a novice. At 29 years old, he had survived 2 years of frontline combat, first as a standard rifleman and then as a designated marksman after his company commander noticed his consistent accuracy during the defense of Voronezh. He'd accumulated 47 confirmed kills with his SVT-40, most at ranges between 300 and 500 meters. He maintained his rifle obsessively, cleaning the gas system daily even when his hands were numb from cold. The weapon was an extension of his body, and he understood its ballistics intuitively. But understanding ballistics meant understanding the problem. The 7.62 4mm light ball cartridge used a lead core bullet with a copper jacket. Upon impact, the soft lead would deform, spreading energy across the target but also losing penetrative ability against hard surfaces. Armor-piercing rounds solved this with a hardened steel core that maintained structural integrity on impact, concentrating force on a smaller point and punching through barriers. Belov didn't have access to B-32 rounds, but he had access to something nearly as useful: battlefield salvage and a basic understanding of metallurgy from his pre-war work in a Leningrad machine shop. On the night of December 14th, after his failed engagement against the German officer, Belov approached Sergeant Dmitriev with a proposal and a handful of components. From destroyed German vehicles, Belov had scavenged hardened steel bolts, specifically the high-tensile fasteners used in engine assemblies. These bolts were manufactured from chromium molybdenum steel, heat-treated to withstand extreme stress. They were harder than the mild steel in German body armor. His modification was crude but theoretically sound. Using a bench grinder in Dmitriev's field workshop, Belov carefully shaped the bolt shanks into cylindrical cores approximately 7.62 millimeters in diameter and 28 millimeters long. He then pulled standard 7.62 54mm RSAR cartridges apart, removing the factory bullets. The improvised steel cores replaced the lead cores, and Belov reseated them in the brass cases using a simple hand-press tool. He adjusted powder charges slightly downward to account for the increased weight and hardness, preventing overpressure that could damage his rifle. The resulting cartridge violated every Soviet ammunition regulation. The steel cores were uneven, the weights inconsistent. The rounds would never pass inspection at an arsenal. But Belov wasn't interested in passing inspection. He was interested in killing Germans wearing body armor. Testing happened at dawn on December 16, 1943. Belov, Dmitriev, and 3 other marksmen from their company moved to an abandoned farm 2 kilometers behind Soviet lines. They'd salvaged a section of German Sappenpanzer armor from a destroyed assault engineer killed during the previous week's fighting. The plate, measuring roughly 25 by 30 centimeters and 3 millimeters thick, was mounted on a wooden frame at 300 meters. Belov loaded 5 of his modified cartridges. The other marksman watched through field glasses. The first shot felt different. The recoil was sharper, the report slightly louder. Through his scope, Belov saw the impact point. A clean hole punched through the center of the armor plate. No deformation, no deflection, complete penetration. He fired the remaining 4 rounds. 4 more holes appeared in the steel. At 300 meters, his improvised armor-piercing ammunition achieved 100% penetration against German body armor. The implications registered immediately. Dmitriev examined the plate. The entry holes were ragged but decisive, roughly 8 millimeters in diameter. The steel cores had maintained integrity through impact. Behind the plate, the wooden backing showed deep gouges where the cores had continued their trajectory. A human torso at that distance would have suffered catastrophic internal trauma. Belov's modification worked, but it came with significant drawbacks. The improvised cores, being harder than standard copper jackets, wore barrel rifling faster. The uneven weights meant accuracy suffered beyond 400 meters. The rounds dispersed into a 15-centimeter group, where factory ammunition would hold 8 centimeters. The modified cartridges sometimes failed to feed smoothly from the SVT-40s magazine due to slight dimensional variations. None of that mattered to the marksmen present. They weren't trying to compete in shooting competitions. They were trying to kill enemy soldiers wearing armor before those soldiers killed them. 15-centimeter accuracy at 400 meters was more than sufficient for torso shots. Faster barrel wear was irrelevant when the average combat lifespan of a frontline Soviet rifleman was measured in weeks. Word spread through the rifle company within hours. By December 18th, Dmitriev's workshop had produced 200 modified cartridges distributed to 8 designated marksmen. The steel came from salvaged German vehicles, the tools from field workshops, the brass from expended factory cartridges collected after engagements. The entire operation existed in the gray zone of plausible deniability. If questioned, the marksmen would claim they were using standard issue ammunition. The modified rounds looked nearly identical to factory cartridges unless examined closely. The first combat test came on December 19th during the assault on a German fortified village outside Zhytomyr. Belov engaged a German officer directing artillery fire from behind a stone wall at 380 meters. The officer wore visible body armor, the distinctive steel plate reflecting morning light. Belov fired once. The officer collapsed immediately, the steel core punching through armor, ribs, and lungs. No second shot required, no wasted time, no repositioning to find a different angle. The engagement lasted 3 seconds from target acquisition to confirmed kill. In the next 4 hours of combat, Soviet marksmen using modified ammunition killed 7 armored German soldiers at ranges between 320 and 450 meters. German assault teams that had advanced with confidence suddenly found their protective equipment worthless against Soviet rifles. Officers who believed themselves safe behind steel plates discovered they were as vulnerable as any other soldier on the battlefield. The psychological impact was immediate and profound. The technical analysis came quickly because Soviet commanders, despite the modification's illegal status, recognized immediate tactical value. Within a week of the first combat successes, Rifle Division intelligence officers were investigating. Rather than discipline the soldiers involved, they documented the innovation. Testing by Soviet field engineers confirmed what Belov had discovered through trial and error. The improvised steel cores, averaging 8.2 grams compared to the standard bullet's 9.6 grams, achieved penetration through superior hardness rather than mass. The chromium molybdenum steel from German engine bolts, rated approximately 45-50 on the Rockwell C scale, significantly harder than the 30-35 rating of German Sappenpanzer armor plates. Upon impact, the softer armor steel deformed while the core maintained structural integrity. Velocity measurements taken with available equipment showed the modified rounds leaving the SVT-40s barrel at approximately 2,850 feet per second, slightly slower than factory ammunition due to increased friction from the harder cores. But the reduced velocity mattered less than the penetration mechanics. The hardened cores concentrated impact energy on a smaller point, effectively functioning as miniature armor-piercing projectiles. What engineers discovered most critically was that the modification required no special tools or facilities. Any frontline armorer with access to a grinder, hand press, and salvaged steel could produce functional ammunition. The process took approximately 20 minutes per round, including pulling factory bullets, shaping cores, and reassembling cartridges. A single workshop could produce 50 to 60 rounds per day, while maintaining normal repair duties. Intelligence officers realized the modification addressed a vulnerability Soviet logistics couldn't solve through normal channels. Rather than suppress the innovation, they began quietly documenting it. Field manuals wouldn't officially recognize the technique, but training officers started mentioning it in verbal briefings to designated marksmen. The phrase used was deliberately vague. Field expedient ammunition enhancement using available materials. Soviet commanders adopted a pragmatic approach. Officially, the modification remained prohibited. Unofficially, commanders in active combat sectors ignored it. The reasoning was simple mathematics. A marksman using modified ammunition could reliably eliminate armored targets at 400 meters. That same marksman using standard ammunition would waste 3 to 4 rounds attempting the same kill, might fail entirely, and would expose his position through extended engagement. In fluid winter combat where ammunition resupply was uncertain and enemy counterattacks constant, efficiency meant survival. The modification spread through informal networks. Veterans showed new arrivals. Armorers shared techniques during inter-unit coordination meetings. By January 1944, rifle divisions across the First Ukrainian Front had marksmen carrying small quantities of modified ammunition specifically for armored targets. Standard practice became carrying 20-30 modified rounds alongside regular ammunition, using the improvised armor-piercing cartridges only when targets wore visible protection. German forces never understood what had changed. Intelligence reports captured later in the war showed confusion about increased Soviet penetration against body armor. Some German commanders theorized the Soviets had issued new armor-piercing ammunition to infantry. Others blamed manufacturing defects in armor plates. The actual explanation, frontline soldiers hand manufacturing improvised armor-piercing rounds from battlefield salvage, apparently never occurred to German intelligence analysts. It was too crude, too improvised, too far outside standard military-industrial doctrine. Most critically, the modification demonstrated the Eastern Front's fundamental character. This was industrial warfare fought by armies of millions, but victory often came from individual initiative operating outside formal systems. Soviet weapons designers in laboratories couldn't address the body armor problem quickly enough to matter. Soviet logistics couldn't redistribute specialized ammunition to meet tactical needs. But a veteran sniper with a grinder and salvaged bolts could solve the problem in an afternoon. The Red Army's strength was never superior equipment or comfortable logistics. It was adaptability born from desperation and commanders smart enough to ignore regulations when those regulations got their soldiers killed. The immediate statistical impact was measurable but never officially recorded. Soviet after-action reports from January through March 1944 showed increased kill efficiency among designated marksman units, with average rounds per kill dropping from 3.2 to 2.1 when engaging enemy leadership and specialized troops. German body armor, which had provided a tactical advantage for 3 months, effectively became obsolete against trained Soviet marksmen by early 1944. Junior Sergeant Nikolai Belov survived the war. He continued fighting through Ukraine, Poland, and into Germany itself, accumulating a final tally of 89 confirmed kills before the surrender in May 1945. He never received recognition for his ammunition modification. Soviet military honors rarely acknowledged innovations that technically violated regulations. After demobilization, he returned to Leningrad and resumed work as a machinist. He died in 1987, his wartime improvisation known only to veterans who served alongside him. Sergeant Pavel Dmitriev received a reprimand in February 1944 when a visiting logistics officer discovered modified ammunition in his workshop. His company commander quietly filed the reprimand and told Dmitriev to be more discreet. Dmitriev continued producing modified rounds until the war's end. He survived and eventually trained post-war Soviet armorers, though he never officially documented his wartime ammunition work. The modification itself disappeared with the war's end. Post-war Soviet small arms development moved toward standardized cartridges and dedicated armor-piercing variants manufactured in arsenals. The improvised steel core rounds became historical footnotes, mentioned rarely in veteran memoirs and never in official military histories. They existed in that gray zone of wartime necessity that peacetime doctrine couldn't acknowledge. Technically illegal, tactically essential, quietly tolerated. But the underlying lesson influenced Soviet military culture. The Red Army's post-war doctrine emphasized tactical flexibility and adaptation under adverse conditions. Training for Soviet soldiers included improvisation techniques, battlefield salvage, and field modification of equipment. The philosophy was brutally pragmatic. Regulations existed to maintain order, but survival took precedence when regulations became obstacles to victory. German development of infantry body armor never recovered its tactical advantage. The Sappenpanzer plates continued in limited use through 1945, but German commanders recognized that the protection had become unreliable. Soviet riflemen were somehow penetrating armor that should have stopped their rounds. Rather than investigate why, German industry focused resources on more critical needs, replacing destroyed tanks, producing aircraft fuel, manufacturing artillery shells for desperate defensive battles. In the final analysis, the modification represented something larger than its tactical impact. It demonstrated how total war pushed soldiers beyond formal doctrine into survival innovation. The Eastern Front was industrial warfare on an unprecedented scale, but within that massive machinery of millions of soldiers and thousands of tanks, individual ingenuity still mattered. A single sniper with a grinder could change tactical calculus for an entire division. A workshop sergeant willing to ignore regulations could keep his unit's marksmen combat effective when the logistics system failed them. Today, the story survives primarily in scattered veteran accounts and the technical curiosity of historians who study small arms modifications. No museums display Belov's improvised ammunition. No official Soviet military histories credit his innovation. War has always been a contest between what regulations permit and what survival demands. Armies create rules to maintain order, standardize equipment, ensure logistics systems function smoothly. But those same rules can become obstacles when battlefield reality shifts faster than bureaucracy can adapt. The soldiers who survive are often those who understand which rules to break and which to follow. Nikolai Belov's modification succeeded not because it was elegant or sophisticated, but because it solved an immediate problem that official channels couldn't address. He didn't wait for weapon designers in Moscow to develop new ammunition or for logistics officers to authorize redistribution of existing armor-piercing rounds. He found salvaged steel, shaped it with available tools, and created a solution that kept him and his fellow marksmen alive. One grinder, one bag of salvaged bolts, one veteran sniper who refused to accept that German body armor made him ineffective. That combination changed tactical calculus across an entire front and reminded both sides that industrial warfare ultimately depended on individual soldiers making decisions in cold workshops far from headquarters. Sometimes the most important innovations in military history aren't developed in laboratories or proving grounds. They're improvised in field workshops by soldiers who understand that survival doesn't wait for proper authorization. And sometimes those improvised solutions prove more effective than anything the official system could have provided. Superior equipment matters. Superior adaptability matters more.